Miguel Useche, se fala espanhol, mas é isso aí, pode bater palma pro cara.
So here I am, going all the time, looking all the time, feeling youngest in my mind. So here I am, doing everything I can, holding on as though I am, pretending I'm a Superman.
Hello, it's going. Yeah, all the technical issues are solved. So, well, I'm going to talk about WebAssembly, and it's going to be more like an introductory talk. For those who don't know me, my name is Miguel. I'm a freelance web developer, also a university professor. Also, I've been a volunteer and co-founder of many Hispanic open source communities. I'm a Mozillian from Venezuela, currently living in Colombia. And that's my nickname in most of the social media accounts, so you can follow me in there. This is where I'm from. I'm from a city near to Colombia, and I was really impressed because I took a 7-hour flight just to be in the next country, which is Brazil. I got impressed how big is Brazil until you take a plane. And it's really been a really good experience to be here. And if you wanted to know how I feel right now, I feel like this, because I've eaten a lot of meat, honestly. So it's the best meat in the world. So okay, let's start. Everybody here, of course, loves JavaScript. And I think that when you love JavaScript, it's like loving your soulmate, your girlfriend, boyfriend, your partner. Because even if you love it and you like it, you know that it has some issues and some problems. Yeah, that's pretty normal. And you just ignore it. Usually just ignore it, or you make a workaround to make everything okay. And the same applies for JavaScript, because JavaScript has some problems. And one of the problems is the performance. Because even JavaScript was designed very quickly, and it wasn't designed to be fast. So even if developers have tried to do their best, it's like a race that we can never win, because there is a limit because of JavaScript design. So let's see how the browsers execute JavaScript. And the way the browsers execute JavaScript is like you see in the picture. Is like, for example, some of you are listening in Portuguese, because there is a translator that translates my English sorry, he hears my English, he interprets it, and then translate it and tell you in Portuguese, which is a slow process. And that's how JavaScript runs. There is a JavaScript code that it's parsed. Parse means that it's going to see if the code is well written, if it makes sense, if it doesn't have any syntax error, etc. And once that ends, it just compiles, makes some optimizations. There is a second round of optimizations that can only be done after a previous step, and then it's getting executed. And this process is really slow. And let's see for an example to see this. Usually when we are learning JavaScript, we start with a function like this. It's pretty simple, just 2 parameters and an addition that is being returned to the function that it's being called. And this is really simple, right? It's just only a sum inside a function. And it should be just one CPU instruction. I mean, the CPU should be doing in a single instruction because it's just a sum. But actually, it isn't. In JavaScript, we see the ECMA262. ECMA262 is the definition of JavaScript. And the definition for a sum is something like this. It's like 7 steps. Why? Because it needs to do multiple things. For example, if one parameter is a string, he has to check if it's a string or it's a number. If it's a number, then he has to check the second parameter if it's a string or a number. And based on the combinations, it makes the sum, or it could, join them in a single string, etc. So, and something that should be just one single CPU, like a sum, it's just 7 steps. And if we put this in a loop, you can imagine how slower we'll get in time. Let's see another examples. 1 second. So for many of you that already work with JavaScript, this seems like pretty normal, and say, oh, this is obvious. But people who program in other languages and come to this world, they get frustrated because these things may not have sense. And usually when they are coding, in the application gets some, they might introduce new error, new bugs, and actually it's a problem that happens. Also, well, you might wonder why this happened, because you have to make some sacrifice. We need to make language programs that are understandable for human beings, but the machines only understand low level, so you have to make a balance between one of them, because we can make low-level programming languages, but it will be harder to do, and also we don't need to our application to be run 100% efficiently, etc. Oops. So that's why we make a balance between high-level languages and low-level. So how we can solve this? We can solve it with a new technology called WebAssembly. WebAssembly is a new way to run third-party languages in your browser. Because before WebAssembly, the only way that you can control the DOM and do things in your browser was through JavaScript. And the idea is that you can code in any other language like C++, Rust, C, Go, etc., and run that code inside your browser without any plugins or any additional software that you need to install. WebAssembly is a binary format. That means there is only ones and zeros. It doesn't replace JavaScript. People, when think about WebAssembly, usually think that, no, this technology is going to erase JavaScript and there is no need to use more JavaScript, but they are wrong. Actually, that's why the logo, it's like two puzzle pieces attached one or two to each other, because actually the idea is that they coexist in a single environment. Also, it offers an interface for your language. That means that if you code in C++, Go, Rust, or Java, you can call JavaScript functions, and inside you can call JavaScript functions, and inside JavaScript, you can call your language's function without doing anything special, just like if it was written in the same program. Also, it has integration with API, Web API. What does it mean? That you can access to WebGL, Web Audio, WebSockets, all the technologies that the web offers, you can access through in WebAssembly. Also, it adds a new types of variables and new technologies that JavaScript doesn't support. Also, it's easy to compile, verify, and to extend. That means that we can make new versions of WebAssembly and become fully compatible with previous versions, and we don't have to worry about things like, I don't know if you remember Flash, Adobe Flash? Yeah, some sad faces in there. Yeah, and I don't remember if you went to a website and suddenly it says you cannot see the website because you doesn't have the correct version. Well, the idea is that doesn't happen with WebAssembly. And also, it offers memory blocks of 1 byte, so it's really easy to control the memory because it's segmented or divided in 1 block bytes. Also, let's see how a browser executes WebAssembly. It will be, the analogy, it's like when two people are speaking the same native language, so the conversation will be fast, because all the previous steps that we said about thinking and analyzing will be removed. It will just, in this case, WebAssembly code will be run in just like any machine code. And you can see, it's something like this. There is a decode step that when it checks what the WebAssembly instruction, what it does. It just decodes it, then it compiles and do some optimizations, and then it just executes, which is faster than running straight JavaScript. And the good thing is that this process can happen while you are downloading the WebAssembly module. So you don't have to wait until it downloads all the bytes. You can just download a section of it and start running the code. WebAssembly offers multiple formats. One of the formats is binary. It's just one and zeros. Here you can see in hexadecimal. And there is a cool tool that you can use to study this. It's called WASM Code Explorer. And you can see things like, for example, the first 4 bytes indicates that it's a WebAssembly binary. It's not just any one of zeros file. And also includes, for example, the memory, the code for functions, etc. So it has a well-defined structure. Also, there is a text format. This is the way that you can program. With binary, you don't write in 1 and 0. You use a tool to generate that module. But also you can do it like this. It's like working with assembler, which is a nightmare, but it exists, just so you can write a low-level code. You may wonder why does something like this exists. It's because some people want to run a low level and be sure that everything that they are coding is what it's running. And for example, banks or things that requires like extra security or full security needs to be coded in this. Because I know some guys that work in a bank and they work in a communication model like this because they don't trust the compiler. Or they are afraid that the compiler in the future, in a new version, something changed and generates a different binary. So they like to do this, so they are 100% sure that the code that is running in the browser is what they want to do. Maybe you think that this is like a trendy fashion or something that is not going to be used in the future, but actually no. It has a lot of support. All the main browsers support WebAssembly. Currently, you can run WebAssembly in 86% of the browsers without doing anything, installing nothing. You just code it and host it, and that's it. And actually, I think this is one of the few technologies that all browsers have supported since the beginning. Usually when a browser supports something, the other doesn't like it or creates a copy, and it's like a fight between each other, but with WebAssembly, everybody was agreeing that this is something that has to be done, and they are working together to make it work. Now you may wonder, how can you create WebAssembly? There are multiple ways to create WebAssembly. One is like the supposed one. I mean, the one that it's going to be in the future and the way that it's designed for. It's a compilation target. That means that you can write in your favorite language, and when you're compiling, you can select WebAssembly as a result or as a compiled target. For example, Go works like this. You just export some variables, global variables, and then execute the compiler, and it will automatically generate your WebAssembly module. So the code that you write in Go will be translated into WebAssembly. And then you can run it in a Java virtual machine without any changes. For Rust, which is a pretty good language for multi-threading stuff, and you can give it a try, you just have to download a tool called WASM pack, and you just click WASM pack, view, and it will automatically generate the WebAssembly. So there is no such thing, something new that you have to do. You just execute those tools, and you get the module. The other option is use a tool called mscripting. This is how other languages work, and this is how initially you generate WebAssembly code. Mscripting is just a set of tools that lets you take high-level languages to low-level languages. The thing that you need to know is that there's something called LLVM. LLVM is all compilers generate this code. Because, for example, if you want to write a tool for a PlayStation, an Xbox, an Android, Windows, you don't need to write 5 or 6 different compilers. You just write like a semi-compiler that creates LLVM, and then there are already tools that takes LLVM for a PlayStation, for an Xbox, etc. It's like a middle code. So what mscripted does, it takes LLVM, executes its internal set of tools, and lets you create WebAssembly. This sounds complex, and it is complex in behind, but actually what you just need to do is execute a command, and that's it. Just download the tool, execute the command, and it will transform some code into WebAssembly automatically. That's how you program in C++ and how you take C++ to WebAssembly using this tool. Also, there are some other external tools that you can use to take the one language to WebAssembly. For example, in Java, you just download bytecoder, and bytecoder, it will take the JavaScript, pre-compiled JavaScript code, and will move it to WebAssembly. Now, you may be wondering, okay, what do I get after doing these things? After you do these things, you will have 3 files. The WebAssembly file, which is just a binary file, the 1 of zeros, the one that you are going to run. It is just a module, just like any other JavaScript module will be inside this file. Then you will get the JavaScript file to load this module, and then the HTML just to run it inside the browser. So there is nothing complex or something that you need to do. Actually, you just need only this file, and you just load it in like any other binary, and that's it. Now, let's see how you can interact with the code. Because the idea is that you can make multiplication in multiple languages and take it to the web. Or you can just interact between JavaScript and your application, because that's the cool thing about WebAssembly, that you can come and create in multiple languages and put them in a single application. For example, this is how you call C functions from JavaScript. mostly all languages has a restricted word called extern. Extern tells to the compiler that, hey, this code is not going to be run here. It's going to be run by a third party or an external source. So in C++, you just wrap your code inside this external block, and then in JavaScript, you just import it like any other module, call this function called cwrap, and then you pass the name of the function, the expected return type, and just any parameters like this. For example, then you can just use it just like any other functions. For example, in this case, you may use the square root from C++ because it has better performance, or it can give you better decimals. Because JavaScript, I don't know if you have worked with JavaScript and decimals. It's really hard because sometimes it doesn't give you the correct value. So many people might use C++ because it's faster and give you the correct value, and then just from JavaScript call that, and it will run faster than before. Another way is to do the opposite. To do the opposite, there is, for example, it depends on the language. For example, in C++, you have this function that you just pass all the JS code, and it will be run automatically. Or there is something that you can call with AMSEM, and then you can write like you code like you would do on JavaScript, and it will run inside the C application. For Rust, it will be almost the same. You just, again, extern to import to tell the compiler that, hey, this code will be run outside. Then you just add that tag to each function, and for example, the function is called float square root, and then in JavaScript, you just import it just like any other module. And with the module, you just call the function with for example, the module is in this JS variable, then you just make a promise, and when it finishes to be imported, you just put point, the same function name, and pass the parameter, and that's it. I mean, it's really easy. So you can see you don't have to learn anything new, just how to compile things to WebAssembly. And also the opposite is you can just you can just import this object, and then you start to call in the functions just like it was a normal JavaScript code. Now, you may wonder, okay, this is cool, what can I do with it? So, for example, this is a demo that Epic Games made for Firefox. They port the Unreal Engine inside the browser. What's the cool thing about this? That you don't require any plugins, you don't need to install anything. Just go to a website, it will be running there. And for example, all the OpenGL code will be translated into WebGL. All the audio will be translated to Web Audio. There are some things like, for example, the threads will be transformed into a service worker, so you can run parallel code. And the cool thing is that you don't have to worry about doing that because WebAssembly will do that for you. And it will run just like any other game. As far as I know, it took 3 days to do this, to take some code to port the Unreal Engine into WebAssembly, so it's not something that difficult. This is just a picture about a web editor that you can see later, because you can now, for example, things that were impossible to do before, you can now do it with WebAssembly. For example, doing facial recognitions, of applying filters, so like a snapshot. For example, if you want to make a snapshot client with JavaScript, in the past it was almost impossible because JavaScript didn't have the performance to apply the filters. Now with WebAssembly, you can do things like this. And for example, there are some filters that runs 1,000% faster than JavaScript. So that's one of the things where you can use WebAssembly. There is a new version of Google Earth that you can use, and it runs WebAssembly, which it is faster. And it has better graphics than the previous one, and you will see that it doesn't feel like heavy or your computer is like forcing it to render this because it runs really fast. Also, Kenneth already said in his presentation, but AutoCAD announced that they are porting their application into the web. Currently, it only runs on Firefox, but there are plans to support Chrome. And the idea is that you can have AutoCAD inside the web. This is a really great use case because they have 35 years old code inside the application, and they could port it into WebAssembly. And also they have they have C from 35 years, C from 2 years ago, and they will able to migrate everything to WebAssembly. Also because, for example, you can now port native apps into the web without doing anything else. For example, for AutoCAD, it doesn't represent to maintain or create a new web application. It's just the same application that they have for desktop taken to the web. without any plugins or any new dependencies. Also, this is a demo that I recorded. It's Doom 3 for inside the browser. I know that Doom 3 is a 15-year-old game, but actually when it came out, I don't know if you remember, it really required computers that they didn't exist in the time. So actually, Doom 3 is more like a 10-year-old game, and it runs, you can see the frame rate, it runs around 40 and 60 frames per second. The hardware that I use is the cheapest Mac that you can buy in 2015, so it's not something with a really good card or good processor. Actually, it's a 1.4 gigahertz processor, so it's nothing. It's not a good machine. It's just a simple machine that we could say that it's just a basic machine, and it runs really smooth. It doesn't run on high-level settings, but I would say like it's a medium settings like that. And there is, like I said, there is no need to download anything else, just the map and of course the game code. Another tool, I don't know if you know WordPress. I don't know if you love it or hate it. But in the new version of WordPress, they have an internal post editor. And the post editor uses like a set of blocks that you can build the application, build the page, just like the browser will see it. And those blocks require in the background, it uses a tree. So doing the tree in JavaScript was really heavy, and in the first versions, if you use it, it was a really, really slow application. So they ported to Rust, and they started to migrate to WebAssembly. And if you can see the test, for example, the increase in speed up is a lot. So for example, 96 times faster, even 100 times faster, and there is one test that runs 300 times faster. So the improving in speed is really, really fast. Why? Because languages like Rust or C++ or Go can do these kind of things faster. For example, math calculations, navigating through a tree, etc. It's way more faster. So it's better to code them in those languages. You compile to WebAssembly, and then just import into JavaScript application, and just make the calls, and that's it. So it will improve a lot. Actually, I think Angular is doing that with the DOM manipulation, and React it's already doing. They are migrating part of the DOM manipulation code. I don't know which language, but I know that they are compiling into WebAssembly, so it will run faster. And the new React version will run even faster without doing any code change or something for you. Another demo is, I don't know if you have used Google Keep in the past days. They now added a feature where you can draw, you make your internal notes, and the cool thing is that that's done through WebAssembly. There is an existing library called Ink that it's written in C++, and they took it to, actually I think it was designed for iOS, and they bought the library, they just took the source code and compiled it into WebAssembly, and they just imported it into Google Keep. So that's how you can make those draws and draw in real time without any performance issues. My pulse is really bad, so that's why it doesn't look good. And now you can be a full stack in multiple languages. So in theory, your dream may come true, and you can have a front-end PHP application with a back-end PHP application. So go to the full stack and not using JavaScript. But of course, this is something bad to do. But it's doable, because sometimes, I don't know, maybe you have an old code written in some language, or you don't want to redo it, or it works okay. There is more risk to port into a new language than using that, so it's better to take existing code. Currently, there are new features that it's being added. One is SIMD. It's a set of instructions, mostly for matrix operation. What does it mean? There are things, for example, if you want to multiply two matrices or two arrays, it will be, instead of doing it in multiple phases or multiple instructions, the processor will do it in a single instruction, so it's really fast. That means that you can do cryptographic stuff, or playing, for example, you can create your own HD codec and play videos, and it will be run faster with this set of instructions. The other thing is multi-threading. Currently, it's been implemented through Service Worker, but there is some, Firefox and Chrome are working to use the operating system threads. So once they detect that WebAssembly requires a thread, you just send it to the operating system, so it will run faster. Also, there is support for new types. Now there is a JS big integer, and now the idea is that that type will match with any float or its counterparts in C++ or Rust, etc. There are new features that it's going to be added because, like I said, WebAssembly is something that is going to be growing each version of the browser. One is the treatment for exceptions. So actually for us, exception is pretty simple. You just put a try and catch inside a code and what action to do if something fails. But to implement that inside a compiler and inside an interpreter, it's really hard. So they are working on it. So you can now have the exceptions translated into the same as JavaScript. Also, they are adding a garbage collector, so you don't have to worry. So this is pretty good because you can create a C application and not worrying about the memory, because when it gets translated to WebAssembly, the garbage collector will take care of the memory. Also, it will let languages like Java or Python to be implemented in WebAssembly without any hacks or migrating their interpreters. Also, global variables, mutable global variables, which is used for multi-threading, it will also be natively supported. Now you don't have to wait for this. This is not something in the future. This currently happens, so you can try you can go after this conference and start trying to do things with WebAssembly. There is a tool called WebAssembly Studio. It's just a IDE that runs in the browser, and you just go in there. You have already an IDE. You can select examples in C++ or in Rust. I don't know if they had added any new languages. And you can start coding things and start hacking and creating things. So yeah, just go to WebAssembly, write a new application, or take your older application into this one and start hacking and testing to see how the performance runs and how you can do new things in the web thanks to WebAssembly. I will share the slides with you, and they will contain a lot of links so you can start hacking and working with this. And obrigado pela atención. And there's my website and pages.